Picture this, a silent, sterile auditorium at the edge of the galaxy. An alien professor of xenobotany is presenting the crown jewel of his research. Floating in a shimmering stasis field is a small, green plant. He explains to his class, a wild assembly of beings from a dozen star systems, that this is specimen 734 from a quarantined Class 12 death world. Its tissues are laced with a compound so virulent that just touching it causes catastrophic cellular meltdown in most mammals. He runs a simulation. A creature like a small Earth rodent makes contact. Its body convulses. Its vital functions completely shut down. The whole thing is over in less than 30 seconds. The class recoils. A student, who looks like a walking fern, starts to quietly sob, but from the back of the room, a single hand goes up. It belongs to the class's lone human exchange student, who leans forward and asks a question that will change xenobotany forever. "Sorry, Professor, are we going to get to taste that?" The professor, a towering Quarian named Creel, just lets the question hang in the air. The only sounds in Xenobotanical Hazard Amphitheater 3 are the hum of the stasis field and the fern student's whimpering. Professor Creel's bioluminescent skin, usually a calm swirl of blues and greens, flashes a confused violet. He dedicated his entire life to cataloging the millions of ways the universe could kill you. This lecture was supposed to be his magnum opus, a chilling warning about the quiet horrors lurking in the cosmos. He gestures a spindly, three-fingered hand at the floating plant. "Human Alex," he begins, his voice a series of melodic clicks. "I think you're missing the point. This organism from the planet you call Earth isn't food. It's a biological weapon. To prove it, Creel runs another simulation. He shows the class tests from 3 different star systems. Rodent analogues, primate analogues, even a famously tough silicon-based life form, all of them snuffed out in under a minute from a microscopic dose. The active compound, he explains, is a powerful irritant that triggers a systemic shock so immediate, so overwhelming, that the subject's vital functions just cease. The heart stops. The lung seize. It is one of the most efficient single-contact poisons we have ever documented for mammalian life." Alex, the human, nods along. Right, I get that," he says, pulling a small metal grinder from his pocket and twisting it idly. "It's a capsicum annuum. We call it a jalapeno. They're pretty mild, but you have to get rid of the seeds if you don't want heartburn." He gestures with his grinder. "My Uncle Dave grows these in his backyard. He says the key is tons of sun, don't overwater them. Of course, he's more into Carolina Reapers. Now those will actually make you cry, but you know, in a fun way." The silence in the room goes from quiet to a kind of profound, galaxy-spanning confusion. Professor Creel stares at the human, then at the lethal plant, then back at the human. A little floating orb of light, an eye assistant named Tink, zips up to the professor. Its synthesized voice is flat, but it somehow manages to sound completely baffled. "Professor," Tink chirps, "my analysis shows a 98.7% probability that he is not joking. My archives also confirm that capsicum annuum and its more potent relatives are regularly consumed by humans. They appear to enjoy it." The fern student faints, and Professor Creel, for the first time in his 37-cycle career, is utterly speechless. The lecture on galactic biohazards was over. A new, far more terrifying lesson was just beginning, a lesson on humanity. The syllabus was tossed out the window. The rest of the semester and the next few years became a galaxy-wide investigation into what Professor Creel dubbed the Terran anomaly. With Tink's help, he dove into humanity's chaotic data network, and what he found was way more horrifying than any bioweapon. First, he looked into this whole seasoning thing. He didn't just find that humans voluntarily ate the pain-inducing plant. He found they'd spent centuries deliberately making it worse. Tink pulled up records of artificial selection, showing how ancient peppers were bred to jack up the concentration of their active compound. They had turned a mild deterrent into something exponentially more potent. "Professor," Tink reported, "its light pulsing a distressed yellow. The humans have invented a system for measuring this toxin. They call it the Scoville scale. It's not a scale of lethality, but a human-invented scale of pain." The eye displayed a chart. The jalapeno, the plant that started all this, sat at a measly 5,000 Scoville heat units. Above it were peppers Creel could barely process. The ghost pepper at over 1 million SHU. And at the very top, a gnarled, evil-looking red pod called the Carolina Reaper, a man-made monstrosity clocking in at over 2 million Scoville units. They engineered this, Creel clicked, his voice trembling. They took a weapon, and they sharpened it. Tink then showed them the videos. Hot wing challenges with humans sweating and crying, their friends cheering them on. Competitions to eat raw ghost peppers, where the winner was just the person who could stand the agony the longest. It seemed humans hadn't just built up a resistance. They had turned biological warfare into a recreational sport. The investigation snowballed. Professor Creel, in a state of academic shock, started cataloging everything humans did that should, by any rational standard, kill them. He found a substance called ethanol, a known neurotoxin. Humans didn't just drink it. They built entire social rituals around it. They drank it to celebrate, to mourn, and just because it was Tuesday, he learned about jogging, which seemed to be a prolonged, low-level panic response done on purpose for health. He saw cases of humans surviving brain injuries and just going back to work. He watched videos of them strapping planks to their feet and sliding down frozen mountains at lethal speeds, calling it skiing. An ambulatory crystal student named Glix spoke for the first time all semester. "Professor," it chimed, its facets vibrating, "I have to withdraw. My core programming is based on risk avoidance. This is causing cascading logic failures. The galaxy is dangerous, and we survive by being careful. Humans seem to have survived by not." Professor Creel could only nod. He turned to his now half-empty class. "It appears," he said, his voice heavy, "that humans consume pesticides for flavor, drink poison for fun, and treat debilitating pain as a form of recreation. The Terran anomaly isn't that they're hard to kill. It's that they treat death like a hobby. So, is any of this actually true? Can a jalapeno really kill you in seconds?" The short answer is, not even close. The whole story is built on a wonderful, but completely fictional, exaggeration of what chili peppers actually do. That potent neurotoxin in the story is a real chemical called capsaicin. It's what gives peppers their heat, but it's not a neurotoxin that causes catastrophic cellular dissolution. Instead, it's a fascinating chemical trickster. We have pain receptors in our mouths called TRPV1 receptors. Their job is to detect actual heat like from a fire or boiling water and send a pain signal to your brain that screams, "Danger! You're burning!" Capsaicin is a molecule that just so happens to be the perfect shape to fit into that receptor, like a key in a lock. When it clicks in, it triggers the exact same signal as a real burn. Your brain is being lied to. It genuinely thinks your mouth is on fire, even though there's no actual temperature change or tissue damage. That's why eating a hot pepper feels hot and why the pain can be so convincing. It's a false alarm, a brilliant chemical illusion. So, could it kill you? The stories claim that it stops your heart and lungs is totally false. To actually die from capsaicin, you'd need to consume an absurd amount. Estimates suggest a 150-pound person would need to eat about 13 grams of pure crystalline capsaicin. To give you some perspective, that's like eating 2 to 3 pounds of some of the hottest peppers on Earth, like ghost peppers, all in one sitting. Long before you got anywhere near a toxic level, your own body would stop you. The intense pain, sweating, and vomiting would make it physically impossible to keep going, and that Scoville scale? It wasn't invented to measure pain. It was originally a dilution scale. The number just meant how many drops of sugar water it took to dilute a pepper extract until professional tasters couldn't detect any heat. It's a measure of pungency, not agony. This brings us back to the real mystery. If capsaicin is a chemical that plants evolved specifically to stop mammals like us from eating them, why are we the only animal that actively seeks it out? Why do we enjoy this fake pain? Well, science has a few amazing theories, and they paint a picture of humanity that's just as strange as the Sci-Fi Story. One of the biggest theories is something called benign masochism. Psychologists like Dr. Paul Rosen suggest that humans get a thrill from negative experiences when we know, consciously, that they aren't actually dangerous. It's the same reason we ride roller coasters or watch horror movies. When your brain gets that fake burning signal from the pepper, it freaks out and releases a flood of endorphins and dopamine, the body's natural painkillers and pleasure chemicals. It's a rush very similar to a runner's high. You get the thrill and the euphoric chemical reward, all while knowing you're perfectly safe. It's a biological hack for a consequence-free adventure. Another theory looks at our evolution. Capsaicin has antimicrobial properties. In hot climates, before we had refrigerators, food spoiled fast. Spices like chili peppers could have killed off dangerous microbes, making food safer to eat. What started as a survival trick could have easily become a cultural taste we pass down through generations, and part of it is just personality. Studies have found a clear link between people who love spicy food and people who score high in sensation-seeking and risk-taking. These are the same people who are more likely to enjoy extreme sports. For them, the burn of a pepper isn't just a flavor. It's a challenge. It's an experience. It's the same thrill behind eating fugu, the pufferfish. The dish is famous because the fish contains a lethal neurotoxin. But chefs in Japan are licensed and trained for years to remove the toxic parts safely. Poisonings from restaurants are incredibly rare. It's not about actually wanting to die. It's about the thrill of eating something that flirts with danger. So while a pepper that kills in seconds is science fiction, the story gets something right. We're a species that finds joy on the edge of discomfort. We turn pain into pleasure and danger into dinner. What's the spiciest or most dangerous food you've ever tried just for the story? Let me know in the comments below. And if you enjoy exploring that weird line between science fiction and science fact, make sure you subscribe. The story of the professor and the pepper resonates with us not because we think a jalapeno is a weapon, but because it captures a fundamental truth about our species. We're the ones who look at a plant's chemical defense system, a biological sign that screams, "Do not eat," and our first thought is, I bet that would taste great with a little salt. The alien professor's science may have been wrong, but his conclusion was spot on. Humanity's relationship with risk and pain is completely unique. We don't just survive the universe's challenges, we find ways to make them fun. And that might just be the most human thing there is.